So let's begin. People will keep joining in. Let's start our presentation. Hi, my name is Dhaval Badra. I'm the global business head for sales and marketing and inclusive energy. So the reason why we are here is I'm pretty much sure everyone is from biogas sector and everyone knows biogas is one of the oldest renewable energy source. So at Inclusive Energy, our aim is to digitize this biogas, and that is why we have developed a technology called smart biogas. So as today's topic says, digitizing biogas, what are the opportunities? So I would like our first presenter, Vijay Bhopal, who is also the CEO of Inclusive Energy, to give a small overview about the smart biogas. Over to you, Vijay.
Thanks a lot, Dhaval. Just before I start, there is a Q&A function that we would love you to use. It's at the bottom right of your screen. It's the icon with the triangle, a square, and a circle. If you click that, then you will be able to ask questions to us, and we will answer them later. So thanks to everyone for joining. Yeah, we started this company 5 years ago with one of our ambitions was to digitize biogas, and the reason for that is that we had field experience of working in the biogas sector and found it really difficult to do it without digital tools. And the biogas meters that were available were very expensive and still are. So we had an ambition to create a more cost-effective smart meter for biogas, and we've spent the last few years trying to do that. And there's been some successes and some difficulties, as people on the call will know. And the purpose of this call is to really bring you up to date with where we're at, because we've made a lot of progress in the last few months. So smart biogas was made for three main reasons. The first one is to do with finance. I came from the solar sector, off-grid solar, before this, and off-grid solar has been completely transformed by pay-as-you-go. And we believe that there's some scope for the same thing to happen in biogas. And of course, some of the companies that are attending this webinar and others that aren't already do pay-as-you-go biogas without digital tools. Our argument is that we can make it easier, more sleek, more scalable with digital tools. So that's the first part. Second part is about repair and maintenance. There's many examples of biogas being a rural phenomenon, in which getting repairs done in hard to reach places is just very costly, and the business model suffers. So we want to bring solutions that will help people to reduce their operational costs and look after their customers at the same time. And finally, the third purpose is about carbon. Carbon's a huge topic for most of us, I would imagine. And especially in the voluntary market, we are seeing a drive towards quality in terms of MRV in the carbon markets. We believe we have a role to play there and can be useful. So those are the three main reasons. And just to go to the slightly more level of detail, why is digital monitoring actually needed for biogas? Well, there are a few basic things that we can do, and my colleagues will go into more detail on this, but these are the things that we can use it for. One is basic measurements. How much biogas is being produced, how much is being consumed. The second is analytics, which goes into the remote maintenance side, which is how is the biogas actually being used? Is it being used for cooking or running an engine or whatever, or is it being vented, or is it leaking somewhere in the system? We can now go to that level of detail with smart biogas. One part of this that a lot of people might not know about is the value of using digital tools for the end user. We'll go into more detail on that later, but we have developed an app for biogas users, which we're quite excited about, and there's a lot more scope for bringing value to the users as well. And then finally, the two things that I already mentioned, which is remote diagnosis and also carbon. So how are we doing so far? Well, I've set out what the point of this project is and what you can do with it in theory. Where are we? We spent 4 years developing this. We've worked with some people on the call for all of that time. It's been difficult to create a product that's both cheap enough and robust enough to make a difference, because the last thing that the market needs is a very expensive tool that does what Smart Biogas does, because that exists. If you're ready to spend $1,000, then you can buy a different tool. So cost has been a huge driver for us, and we feel that we've really made huge progress in the last few months. And as far as we know, we're the most cost-effective smart meter for biogas in the world. And we're now at the point where we're going from our initial release, our basic product, to something way more scaled up and ambitious. And to give you a brief insight into that, we started with flow measurement of up to 2 cubic meters per hour. We're now going into the hundreds. We're already at 60. We started with pressure measurements at 0.1 bar. We're now going to 5 bar. Maybe there's scope to go even further. We started with just these 2 metrics, and we're now adding on more. We can add on temperature and other sensors to make things more sophisticated for those that need it. Now, the last thing I want to say before passing on to my colleagues is thanks to those on the call or watching this later that have worked with us to get to this point. We really couldn't have done all of this work without you, so we don't take it for granted. Thanks a lot, and I'll pass on to my colleagues.
Thank you, Vijay. Now I will invite Karthik Prabhakar, who is also the Director of Operations, to run us through some current and future use cases. Over to you, Karthik.
Yeah, thanks, Dhaval, and thanks, Vijay. Welcome, everyone. Good evening and good afternoon. I can see people have joined from different parts of the world. We're glad that you were able to make time for us. So going into my presentation, I'm going to talk about some current and future use cases, also along with some benefits that comes with Smart Biogas. So the Smart Biogas hardware, especially the Venturi in the picture, which fits into the biogas pipeline, is designed for different segments in the industry. For example, the National Digester Program in India is categorized into 3, namely small scale, medium scale, and large scale. And in small scale, we have the household and the domestic biogas segments, which operates anywhere between 0.5 to 25 meter cube a day. And in community biogas, it's always coming under the medium scale, that is from 25 to 500 meter cube per day. And for both these segments, we have a 3/4 inch Venturi and a 1 inch Venturi, which can fit in a 3/4 inch line or a 1 inch line subsequently. And it can also be interoperable and interchanged depending upon the size of the plant and the piping requirements at the site. With respect to institutional biogas, it comes under the medium scale, which is 100 to 2000 meter cube a day. We already have a 1 inch Venturi, which is ready to be sold, and we have a few customers already using our large flow meters. We also have a 2 inch Venturi, which is coming soon, which can be useful for slightly larger plants. In industrial and commercial biogas plants, they are huge, with more than 2,500 meter cube a day of production, for which we have a 2 inch Venturi and a pitot tube in the lineup. So it's a work in progress at the moment, which can also be extended to 4 inch and 6 inch pitot tubes for those kind of pipings and those kind of scale. Yeah, moving on, we have 2 sensors in our product. One is the differential pressure sensor that gives you the flow rate and eventually the consumption, and a static pressure sensor. So both of them are non-invasive, means the gas is not actually passed through the sensor. It is just measuring the pressure that is there in the pipeline, which translates into flow rate and pressure. And These sensors are designed for a range of biogas compositions. For example, raw biogas, which has 55 to 75% of methane and high percentage of carbon dioxide and H2S as well. And these are always rich in moisture and H2S. So we have a product ready for this segment in the small scale domestic plant sector. And will be coming soon with a product that will also cater to the medium scale plants for raw biogas. And clean biogas is nothing but it's raw biogas, but it is used in systems where there is a system for scrubbing the moisture and H2S to a certain extent, so that it's not very hazardous in terms of what's passing in the pipeline. So we have a product ready for clean biogas in both small and medium scale plant sector. Purified or enriched gas is biogas upgraded to 90 or 95% methane, which is directly used in restaurants, canteens, and power generators. It's also bottled and transported as CBG to kitchens and automobile filling stations, and it's connected to biogas grid in some places as well. So we have a product ready for small to medium scale plants for enriched biogas. And for all of these compositions, we would also like to enter into the large scale plants, which is being planned as of now. And the smart biogas works in a wide range of scenarios. For example, we have customers who are operating biogas plants with feedstock from animal waste, animal farms, agro-residual waste, Napier grass, municipal waste, and even up to the extent of water hyacinth being used as a feedstock. And with respect to plant types, it can operate. It can be retrofitted, or it can be fixed as the new device in any kind of system, ranging from fixed dome to floating dome, or even a prefabricated bag or FRP tanks. And it can also operate in huge reactors. Smart biogas comes along with a complementing software, and the software has a tool for every stakeholder in the industry. For example, value from digitizing biogas means remote monitoring, performance insights from the digesters, users' behavior, whether he's been feeding and maintaining the digester properly, whether he's been using the gas optimally, or has he been venting it out, and fault diagnosis like leaking, venting, and even in cases of poor production or reduction in production. Also, a digital system makes program management easier. For example, program owners get a web application which enables them to access the status of the various projects, and also gives them a tool for digital measurement, reporting, and verification of carbon credits, which makes the carbon market transparent than what it is today. Program managers and sponsors get an oversight application where they can be as top-level observers looking at and having a check of what's happening in each up and running and things like that. And program implementers get a very data-heavy analytics and reporting tool, which I'll come back to explain in a bit. And value to end users is a mobile application which allows them to get insights into their digesters' performance, their usage, their payments and billing, and the kind of savings that they are making out of biogas. And they are also enabled to diagnose a fault by themselves and report it to a technician through mobile or a WhatsApp call. Moving forward, I would like to discuss a couple of current as well as a couple of future use cases that smart biogas will be catering to, and the Inclusive Energies team is currently working upon. So domestic kitchens and institutional canteens is where the raw biogas is directly used in rural and say peri-urban households as well. The users, the end users, as a motivation, they would like to know their usage and savings on upon switching to biogas. The project owner wants to measure the impact of these installations and report back with the success metrics of the projects to the stakeholders or the owners. The project implementer wants to keep track of all the digesters and whether these installations are upkept over the period of the project. They also want to be able to detect faults, user behaviors, and generate project reports that can be remotely downloaded and presented to the stakeholders. Carbon agencies want to use digital MRV in carbon projects, as I said, and Smart Biogas has a solution for all of these use cases that are listed above. Can you move on to the next slide? Yeah, thanks. So power generation and thermal application is another type of use case that we have been working closely with our customers. Clean biogas is used in these biogas power generators. The operator or the owner wants to know the consumption of these machines or the generator, calculate the efficiency. In general, these generators have negative pressure in the line due to the vacuum that's created. And Smart Biogas is able to measure the consumption and the flow rate accurately with this negative pressure scenario as well. Next. Enriched biogas, compressed biogas, or bio-CNG is all the one and the same, as most of you might be knowing. Here, the gas is purified and is transported in highly compressed cascades of cylinders and filled or transferred into large tanks or storages at power generation sites or heating applications or even in large-scale kitchens. So these cascades are generally filled at a very high pressure, and it is eventually depressurized at the site while transferring them into the storages. So Smart Biogas comes into the picture at this point, where it can keep a check on the gas that's coming into the storage and also the gas that is being consumed by the application or the consumer. So by this, the user is able to promptly notify the supplier to refill the gas as it's being used. And the supplier is able to bill the user based on his usage, and the user is also ensured that he is being billed accurately according to his use. Community plans, these are like picking up a big time, at least I know for sure in India. So these plans are generally operated and the revenue comes back in a pay-as-you-go model, where raw biogas is supplied to panchayat households or kitchens through grid or underground pipeline, or sometimes people also carry balloons or bags to buy the gas and take it back to home. Gas is also transported to highway motels in balloons through trucks. You can see one towards the right in that slide. The Smart Biogas can measure the production at the production site as well as the consumption that's happening at the consumer end, which measures the overall efficiency of the system. This system always needs an easy way of metering, billing, and payment, which is now sorted with the help of Smart Biogas and the software that we have. Enriched biogas for restaurants is something that we are looking to cater to in the very near future. So purified gas is transported via pipelines to kitchens. The pressure requirements are always about 2 bar, because that's what they need in order to be able to use biogas as it is in LPG stoves. And also the density is going to be different to a raw biogas. So Smart Biogas will soon be able to measure consumption accurately with these kind of pressures ranging from -1 to 5 bar. And measuring the usage is very important in this case for building the restaurants periodically. Finally, these are large plants for bio-CNG or power generation. These plants generate more than 100 or 200 meter cube per hour. Enriched biogas is directly used as alternate in CNG vehicles, or it's also used for power generation in large-scale plants. Many of these plants come under the MNRE's, the Ministry of New and Renewable Energy in India, who have announced this SATET scheme, and I believe that some of you here are already participating in it and showed your interest. So Smart Biogas has not entered into the space yet. However, we have the pipe fitting that is required to measure these kind of flows, but as of now, we are not entirely sure of the flow and the line pressure at the point of measurement, and what's the kind of user interface or display kind of things that the users might be wanting to have. So we appreciate people working in this space who can come forward and give us these technical specifications and inputs so we can keep continuing our R&D and deliver at some point in the future. So that's about the use cases and the benefits. Thank you.
Thank you, Karthik. That was really wonderful. Before we move ahead, I would ask everyone to please keep on asking questions in the Q&A tab so we can answer it later once the presentation is over. Now I would invite Gareth Selby, who is the brainchild of this technology and also a CTO at the Inclusive Energy. He will present to you the complete overview of the accuracy and tips on installation best practices. Over to you, Gareth.
Thanks, Deva. Yeah, hi everyone. So we're really grateful again to some of the partners that we've had involved with this project. So I'm just going to mention the University of Nottingham here, who've been with us since the start, and they're our independent partner who carry out independent testing, particularly focusing on the flow rate accuracy of our product. So they've been with us from the start and they're still with us, which is great. As well as the University of Nottingham, we have in-house testing facilities where we carry out our design work. We've got one in the UK in London, and we also now have one in India. These are both designed to ISO 5167, and having the two test sites allows us to cross-reference testing. And the testing is, of course, carried out also in accordance with ISO 5167. So what have we achieved? Smart Biogas has some great performance, actually. For a low-cost sensor, it does very, very well. So the standard range is the most sensitive and has an accuracy of the flow of plus or minus 5% across the flow range. And the raw range is slightly less sensitive with an average flow rate accuracy of plus or minus 7% across the range. The consumption actually tends to be more accurate than that because the plus and the negative 5% or 7% tend to cancel each other out to hit near on 100% accuracy on the consumption. And we're going to publish some more figures on that shortly. If we go to the next slide. So I've added in this slide here just for customers maybe who already historically have bought our meter, because this is something that we found more recently to really help with accuracy. And it's the concept of the entrance length and the exit length, where you have a pipe length before and after our Venturi meter. And what we're trying to do is create a undisturbed entrance and exit length where you don't have any valves, tees or bends or any other fittings that might affect the flow. And that allows a fully developed flow to be achieved by the time it hits the Venturi or the pitot. And then we get the highest accuracy. A rule of thumb is about 3 foot before the meter and 1 foot after the meter. That covers all our products that are currently out there. It's actually slightly less if you're using the 3/4 inch Venturi, but that would cover every product. And there's other installation instructions, of course, in the manual, which I'd always just point you to make sure you follow those accurately. If we go to the next slide. So I'm just going to talk a little bit about the R&D that we've been doing more recently. So we've been working on a high flow rates, high pressure, and specifically very raw sensors. And we've had a customized sensor made specifically for us to specifically suit the needs of biogas. So that allows us to operate for much longer with good reliability for the raw biogas. And also operate for negative and positive pressures from -1 bar all the way up to 5 bar, which is necessary for engines and generators in particular. With that, we currently have on both product ranges cartridge style sensors, which allow easy replacement if required. So as and when, if the worst happens and the sensor does fail, it's as easy as just pulling it out and plugging a new one in. We have great sensitivity, as I've mentioned before. And critically, we measure flow and pressure, which, as we'll come on to later when we look at analytics, that's what really gives you great insights into the performance of the biogas digester. So I'm going to just signpost you here towards the websites, because we've got the full current lineup on our websites, where you've got on the left the standard range, which is our highly sensitive range that operates at slightly lower pressures. And then on the right, you've got the raw range, which is very, very robust, but is slightly less sensitive. You'll notice that each range is split in two ways. One is the flow and one is the pressure. So on the standard range, it operates at either 10 kilopascals or 50 kilopascals, and then flow rates of 2, 4, or 22 meter cube per hour. And then on the raw range, you get higher flows and higher pressures. So you've got 10, 50, and 500 kilopascals, or 5 bar, and then flows of 13, 24, and 62. And also, just bear in mind that there's a minimum flow rate for these products. So you just want to bear that in mind when you're selecting the right products for the right situation. Thanks, Stella.
Thanks, Gareth. That was really insightful. Now, I would request Vijay Singh, who is also the head of customer support at Inclusive Energy. He will run through about the hardware and the software updates that our device Smart Biogas has. Over to you, Vijay Singh.
Yeah, thanks, Dhaval. Good evening and namaste, everyone. So as you know, Smart Biogas is a remote monitoring device, which means the device will be installed where your digester or your installations are, and you need to have the data, real-time data on your dashboard all the time. So that requires to have a technology which is reliable and low cost. So earlier the device was working on 2G, and now we know that 2G is slowly phasing out. So we are now moving to 4G, and the device is shipped with the global SIM card, which means wherever you are, the device comes with the SIM card, and when you install it, it will pick the best network that is available in your area, and the device consumes on average 6 MB a month. So that is a very low data, but at the same time, a lot of our customers face the issue to find the best and the low cost SIM cards for that much of data uses. So now the cost of the data for a month will be around $1 or $2, which is still on average very less than what you pay to the local service provider. In any case, if due to the weather or the network issue, device is not sending data, it will store the data locally for 30 days, and whenever the network is back, it will sell all the data. For all the latest update, the device has a feature to send the latest firmware and keep your device on the latest running firmware that we have. In case if you are doing some customization, which is easily possible on the hardware side. For example, if you purchase a product for 2 meter cube and you want to upgrade your flow to 4 or 6 meter cube, you may need a different sensor or the Venturi. You can get that from us, and we will configure your device remotely for that particular Venturi. So it will also be save a lot of your cost, and you can use the same hardware for different configurations, basically. And earlier, as some of our customers have joined here, they have faced that when they do any troubleshooting or do a local technician do any firmware upgrade, they have to open the case and do connect a lot of wires, which was not very ideal. Now the device has a RJ45 port, which allows you to access the device with that, and the technicians can actually do all the troubleshooting through that. So like on the way how you extract the data, which you know is the pressure and the flow. So one way that device is doing it is sending over the dashboard, that is the software. Other way now we are introducing is that you can see the data on the Smart Biogas itself, and having the screen will change on how you use the Smart Biogas, basically. So in case the screen will be useful in a lot of ways. If for any case there is a issue, earlier there was only LEDs which giving the limitations on how you understand what is happening inside the device if there is a issue. So now it will be on the screen. It will show what is the network, it will show what is the battery, it will show a real-time flow, real-time pressure, and the day you install the device, how much is the total gas consumption so far. So another use case for this can be like if there is a team that is on the digester side, they can actually see the data. So they don't have to go to the dashboard, but if you are doing a remote monitoring, you can go to the dashboard. So it will give both of your on ground team and the remote team easy access to the data. Yeah, so we have improved on our sensor technology. Earlier, we were having an issue where because of the high humidity and the H2S content, the sensors were failing. But now we have improved on that. And along with that, we have improved our range on pressure and flow measurement. So now we have product ready to measure from up to 20 meter cube and 5 bar. So for the 5 bar is going to be launched very soon. Another critical thing for a remote monitoring device is how you power the device, basically. And so the device now have the option to select. You can purchase the device with the adapter if you have a AC power easily available near the device installation, or you can power the device using solar. So that gives you the option to have the installation at any place, at any remote place, because solar is easily available. And we have improved the solar panel as it was before. And earlier, as some of you already know, that you have to connect the battery connector on the PCB when you do the installation. In future, the device is going to be shipped with a switch, which we will ship by switching off the same switch with the device, and you just have to turn on the switch when you do the installation. You don't have to open the top cover for the installation. So that will make your installation very fast and very easy. So yeah, our team was working for last 1 year for all those feedbacks that we have received, and we're looking forward to have more feedback from you and improve the product for you. So I will pass over to Karthik now to introduce how we understand the data.
Yep. Thanks, Vijay. That was wonderful. So to all the different types of audiences here, I thought I can quickly go through data visualization and also a couple of interesting features that we have introduced recently. So the first thing is I'll go through this digester data page. So what's highlighted there is the current status, which means that's it's showing the data from the last report that was sent from the device. So you're seeing what was the latest pressure, what is the latest flow, and what's the total gas consumption, which is from day one of the installation, and also the gas consumption to date. And next, if you go down, you can see that you are able to select a time period, which can be from day, a week, month to several months or a year also. And it shows the statistics for the period that you have chosen. What was the maximum pressure? What is the maximum flow? What's today's consumption and average consumption, etc. And this allows you to do an analysis of what's been happening in your digester over changes in weather and changes in the season from summer to winter to monsoon, etc. So how do you read a graph? So the graph has three parameters that are displayed there. First one is the flow, which is depicted by the green line that you're seeing there. And the units are in meter cube per hour, and the scale is towards the right, as you can see. And the resolution is can go up to as low as 0.1 meter cube in terms of measurement of flow, and anything below that is being considered as leak. And in terms of pressure, you're seeing the orange line on the graph, and it's measured in kilopascals. It can also be shown in bar or kg if required. So that's the pressure. And the third thing is the consumption, which is again shown in meter cube, which is the blue bar graph that you're seeing. So on this slide, you can see various events that can happen throughout the day. For example, you're seeing during the night when people are sleeping, there is no flow. So the green line graph and the bar graph are not there, but you see the pressure is going to its maximum. Pressure is going to its maximum when there is no flow, and it drops drastically when there is flow in the morning when they start cooking at around 4 a.m. or 5 a.m. And you can also see the consumption bar graph going up. So this is a very ideal site of a digester that is performing well, and also a user who is using the digester well. So he's been feeding so that the gas pressure is going to its maximum during the night or when it's not used, and it also comes down when they start cooking. And you would also see that the pressure increases gradually above when there is no cooking for a long period, which is ideal. Next. Yeah, coming on to spotting issues like leaking and venting. So leaking is something that happens when there is no cooking event or when the gas is not being used, but you still see that there is a constant, very low flow on the graph. And it might very well be happening during the odd hours of the day, like late hours or midnight when people are sleeping, and they will probably not be cooking. And the leak might be happening somewhere in the pipeline or at the stove, the burner, the knob, or anything that has been damaged after the meter. And this leakage could cause a lot of data discrepancies. And that's why we are recording this, and we are able to also diagnose a fault or damage in the pipeline and alert the technician or the user to attend to it. And venting is something that happens when the user keeps feeding the digester regularly, but he's not using the gas that's being produced every day. So if he's only using 50% of the gas, the digester is still going to be producing gas at its maximum capability. So the rest of the gas that he's not using is going to be vented through the slurry or through the U-bends, depending upon the type of digester you have, which is not good for the environment as well. So Smart Biogas is trying to detect these two cases and alert the users as well as the program managers. So typically, a leak would be very less, and for a 2-inch burner to be ignited, it needs at least 0.3 meter cube per hour. But a leak would be in the range of 0 to 0.1 meter cube per hour, and it would be very consistent, as you can see in this graph. And the graph towards the left shows a month of leaking data, and towards the right it shows a day of leaking data, where you can see there's a consistent. The flow is not going anywhere above 0.2 meter cube, which is quite not enough for a burner to function. So all of this is leak. Next. And this is venting. As I said, once the pressure is built and the gas is full in the digester, it cannot let any more gas to be filling inside the dome or inside the bag. So the pressure is going to be flatlining, and it would start slowly venting out through the slurry or through the U-bend. So on the left, you see a fixed dome digester that vents out through the slurry, whereas on the right, you see a bag digester where it vents out through the U-bend column, so U-bend which has a water column in it. So there'll be sharp drop and sharp rise when they're not using the gas, but it will be on the higher end of the pressure scale. Next. Yeah, so there are two important features that we have come up with, and it's been developed with a lot of inputs, feedback, and requests coming in from different stakeholders and audience. So one is the analytics tool. So as you see here, this is the homepage of the analytics feature, where you can see the overall analytics of the entire project. That is the complete fleet of digesters that is in the project, and what's the number of digesters, and on a project scale, what has been the number of usage hours or volume of usage, volume of venting, volume of leaking, etc. So this will give you a overall insight of how the program or the project has been functioning, and you'll also be able to derive the success and metrics. And analytics can also be seen on an individual level when you have like thousands of digesters in the field, and you want to just analyze a small sample of that. Then you can select the time period, select the digesters, and then click on analytics. You get the analytics for those digesters alone, and so it also gives you. Can you go back to that slide? Yeah, so it also gives you the events of venting, events of leaking and usage on an individual register level with the number of hours and the volume that's been used or leaked. And on the right, you see there is an events history, which gives you the time at which it was leaking and this thing, and the usage also. So you can cross-check, go back and cross-check this when you see there is an event recorded. Next. And this is reporting. Reporting is something that is useful for project implementers when they have to report to their stakeholders or they want to generate a presentation. Then they can use this tab. So reporting again can happen for all the digesters in one go or for a selected fleet of digesters. And we have two kinds of reporting, which you can do by using the filters that are available. So one is daily consumption report. The other one is the statistics report. Next. Yeah, when you download, you have both these options. The daily consumption report gives you data insights of every day's consumption, and statistics is for over a period, and which can be further analyzed and used in your study. Yeah. So going forward, there's just a couple of other things, payments and billing. So payment plans are available, and you can manage all payments where you're supplying gas on a pay-as-you-go basis, and mobile money integration is quite possible with customization. Next. Yeah, again, you can manage your accounts and team by adding new team members, etc. So we have all the features for that, and you can also pull data to your own platform if that is a requirement using the API keys. And finally, SP Home, as I mentioned, yeah, it's a very useful value add for the end users to keep them motivated and keep using biogas. Next. Next. Yeah. So finally, for getting started, I'm covering this for Vijay Singh. So we always have a demo call to answer your questions, and then an online workshop and training for your team once you've received the meters. And we'll also have a call with the expert during the field installations. And there are loads of useful information. We'll share these presentation slides with you, and you can use these links to go through them. Thanks. That's it.
Thank you, Karthik and Vijay. That was really good. Now let's focus on the Q&A part. I see there are many of questions to be answered. We'll try to cover most of them. If anything is missed out, we will definitely reply you by email, or you can get in touch at info@inclusive.energy. So there's one question from Mr. Victor. Is it possible to turn off the gas supply if the user is venting via the meter? I think Gareth can answer this question.
Hi, let me just turn my, yep, you can hear me, great. Yeah, so currently no. So at the moment it relies on you to take action. So the analytics alerts you that venting is happening. You can then check it on the data, and then you'd have to take action yourself. We are piloting, however, at the moment, and we have prototypes of actuation valves and additional sensors that Vijay Bhopal mentioned very early on, but we're not, yeah, they're definitely not at any product stage yet. And yeah, at the moment it relies on your intervention.
Okay, the next question is from Mr. Rajesh Prasad. He's asking, the biogas meter will be inside the digester. If it's inside, there are chances of malfunctioning periodically due to several reasons, among which moisture is one of them. How to deal with this? So Rajesh, it is not actually inside the biogas digester. It is actually on the consumption side or before the consumption. The next question is, the system current uses SIM card for communication with remote server. When do you plan for a Wi-Fi support? Gareth, would you like to take this one?
Yeah, I mean, currently we don't have that on the product roadmap at the moment, doing Wi-Fi. We did use LoRa in a very early version of this. It's something we get asked a lot, so it's something we're going to consider. And yeah, keep an eye on news from us. It might be something we bring online soon.
Yeah, the next question is from Eric Charles. Can you please describe the method of quantification in more detail? It is based on pressure. What are the limitations in terms of low pressure? Who would like to take, Karthik or Gareth?
Yeah, I'll take this one. So the quantification, we've got flow rate and static pressure. So the flow rate is measured using differential pressure. There's actually two different sensing technologies in both products, but I'll simplify it to saying it's just differential pressure. The differential pressure we get down to, something like 0.13 pascals or something we can measure between, and we measure that every 1/5 of a second, and then we aggregate some of that data and we match that with the static pressure, which is the overall pressure in the biogas plant, and that's with the two sets of data we have a discharge coefficient and a quite complicated equation that we use to then modify that data to make the flow more accurate than you'd get in a kind of standard situation. What I would alert you to is there is a minimum flow rate on our data sheet, which I mentioned before, and that's the minimum differential pressure that we can measure for the different types of sensors.
Okay, thanks. The next question is from Thomas Dory. Is the system still running with batteries or can it be connected to the grid? Well, I can answer that. It has an AC adapter. Yeah, you want to go, Karthik? Go ahead.
Yeah, I just wanted to greet Thomas as well. Thomas, thanks for joining. So, as we explained, we also have a AC adapter which can be connected to the grid if in case you don't want to use the solar panel.
Then there's again a question from Rajesh Prasad. Before passing PSA system, what's the ideal H2S content and which type of scrubber will work best among biological and chemical? Also, what's the frequency of removing membrane used in scrubber? What's the input capacity of H2S? I think this question is Gareth, you would like to take this because it's not related to our system.
Yeah, I think there's quite a lot. There's many questions in this one question. What I'd say is there's a slide that Karthik shared early on in the presentation, which has the percentages and parts per million of H2S and all that. So have a look at that. And yeah, it's written down there. For the raw one, we really don't mind what type of gas you put in. So feel free to throw into it whatever gas you like with whatever moisture content you like. I won't recommend the best scrubbers and things like that probably on this call, but feel free to, I think we're going to share the info at Inclusive Energy email. Feel free to just drop me an email and we'll come back to you on scrubbers that we've seen work and work well.
Yeah, just to add on to that, so biological filters work well as the chemical ones. The biological ones are seen to be cheaper than the chemical ones. That's what we have seen, and that's for enriching or purifying the gas. But for just cleaning the gas, we just need a moisture trap or a moisture scrubber, along with a H2S scrubber, which can be as simple as a steel wool kind of a thing, or some lead or iron pellets through which the gas is passed. And this media has to be replaced in a periodic manner, which you'll get to know as they get degraded and becomes powder once they have been used for some time. So we'll have to replace that periodically. And H2S levels, it can be brought down from like 800 to say around 150 or 200 ppm for safe operation of the sensors.
Yeah, so the next one is for Vijay Bhopal. So Maxence Afre is asking that he understands the carbon project certifier, that is the gold standard, which are more interested in monitoring whether biogas has been consumed or not on a day-to-day basis. Do you have a simpler version of meter which can report whether biogas has been consumed?
The short answer is yes, and hello, Max. You might remember a few years ago, we used a much more basic version of the product and it wasn't very robust, but it is robust now. We can go back to that and that would be cheaper. Obviously doesn't have a lot of the features, but that's usable. And we could also strip out some of the other components to make it the simplest thing possible that would still do the job for you. So get in touch with me directly. You've got my email.
The next question is from AgroGas. Are smart biogas devices ATEX certified?
Yeah, great question. They are not ATEX certified at the moment. We're in the process of certification, so we're working with an external consultant in that process. As we're moving into the bigger biogas plants, we're recognizing that ATEX is naturally required. What I would say is it's designed with ATEX in mind, so very low voltages, no spark risk, no oxygen risk of getting in there. And things like the battery compartment and the flammability of the box are considered. So yeah, hopefully, we're in that process. We hope to get ATEX certification in the not too near distant future. And we'll keep you posted on that.
So there's an anonymous question. If a 4G connection is poor, will the device store the data and then automatically upload it when the connection is re-established?
Yes, up to 30 days. Up to 30 days, the device can store the data, and once it's back on the network, you'll see all the data on the platform and on the graph.
So there is a question from Mr. Sharma. He is using smart biogas from last few months, and it is monitoring the biogas generation on actual basis. As per his research, the biogas validation from different lignocellulosic biomass, an excellent device generating the data online. So it's just a compliment, it's not actually a question. Okay, so does the device, so it's a question from Ashish, does the device have a RS485 serial communication?
So currently, no. Again, we have a prototype which we are releasing in as a prototype. So we're doing field testing in December, where we're working on serial communications in and out of our device. So yeah, watch this space. That is coming. In terms of external communication at the moment, we're pointing customers in the direction of the API. Some customers also connect to some of our serial ports. We've got just some very simple serial ports from pins inside the box. But yeah, that's not something we advertise necessarily all the time. Yeah, watch the space for this new product we're currently testing.
So there is a question from Brian. What is the warranty period for the devices? Any technical support on repair, replacement, and refurbishment?
Yeah, I can answer that. Hi, Brian. Yeah, so the device comes with 1 year warranty, and yeah, we do have the whole support for the installation and the repair. So yeah, whenever you purchase a product, we give a in detail demo about how to install and all that. And whenever you do the installation actually in the field, we also support. So yeah, please write to the support, and for any help, I will be in touch with you.
There is a question from Radhesham Prajapati. What is the price of the device?
Yeah, I'll take
Yeah,
that.
you take it.
We're actually, unusually, we put all of our pricing on our website. So, very transparent. You can just go on our website and have a look. And I just want to add something to Brian's question. Brian, we haven't gone into extended warranties yet, but that's definitely something that we can do. We're confident enough with the new products that they're going to last a lot longer than 1 year. So, if that's what you want, then get in touch and we can talk about extended warranties.
So Brian has a follow-up question. Is there a data protection for data stored and collected by devices? Any NDA signed?
Yeah, I'll take that as well. We have the terms of use of our platform when you sign up is there to read. The customer is the data controller. We're the data processor. So it's fully compliant with the European legislation, GDPR. and there's a confidentiality agreement within that.
The next question is also for you, Vijay. It's from Saroj Rai. Do you plan to produce simpler biogas flow meters? I'm talking about a situation where households are piped to pay for a biogas as per consumption.
Well, the difficulty with that, especially when you're talking about paying for what you use, is it needs to be accurate. So you could simplify it a bit by taking a couple of the features away, but you need the core of the product is necessary, which is the pressure and the flow sensor. Now, Max's question was talking about a yes or no, a binary situation. In that case, you could take the flow sensor out, which would save quite a lot of money, actually. But in your case, where you're talking about pay as you go, you need both. There's no getting around it.
I think we are on time and we have almost completed all the questions. For ones which we have not answered, please write back to us. I think Jordan has already provided the email information where you can drop a message to us. And yeah, that's it. Any further questions? We still have 30 seconds if anyone wants to ask.
There's one more. I'll just take Thomas's question. Any distributors in Eastern Europe? Currently, no. So get in touch if you want to do that. And then there was one missed question, which was, does smart biogas use ultrasonic or Coriolis principle for measuring flow? And Gareth, maybe you can explain what the principle is.
Yes, and it doesn't use either of those principles. It's using differential pressure. So Bernoulli is kind of principle, basically. The reason is just cost, so making it as cheap as possible. So very, very simple. And then also just stopping putting anything into the pipeline that reduces the flow rate. And with that and then static pressure, we get these analytical features, so we can tell the cooking time, if it's venting and things like that, which you can't do with pyrolysis or ultrasound. You don't get all those additional metrics or know necessarily how the density of the gas is changing and things like that.
Yeah.
So before everyone disconnects, there is a small poll questions. We would like to have the feedback of this session. I will be sending it right away. Just take 20 to 30 seconds of yours.
Thanks to everyone for joining. And I'll just answer the last question that came in from Ashish, which is, can third-party sensors be connected? The answer to that is that we are currently making a peripheral device to the main smart biogas unit where we can add more sensors. If you've got something specific that you want us to try and you're willing to work on an R&D project with us, then we can do it. But we don't have the capacity to do everything that people want for one device. But if it's a serious proposition, then we'll definitely consider it. And contact details have been shared in the chat. There's a question from Urja Biosystems. Thanks a lot.
All right.
Thanks everyone.
Thanks, everyone.
Thank you, everyone.
Thank you. Bye-bye.